we have a really exciting topic to talk about. So some of you, yeah, I guess I will start with the introduction of our community. Some of you might know us, some of you, yeah, might see us for the first time. So I'm going to walk you through what we're about. Assuming you can see my screen. Yes. Perfect. So we are ladies at UX Amsterdam. We are part of the global community, which is represented in more than 50 cities all around the world. Actually in Netherlands, we have 2 chapters, one in Utrecht and another one in Amsterdam. And Amsterdam is, is the biggest chapter. We have around 3,000 members, which is really crazy. So why are we doing what we're doing? So we are aiming to promote female talent and increase female visibility in tech, mostly by organizing meetups and talking about this topic. We are also an inclusive community, and we are inclusive to all background, gender, race, and expertise. So don't really be discouraged by the name. It's not only for the ladies, it's also not only for UXers. Not only for people from Amsterdam, especially during Corona times. So yeah, everyone is welcome. Just be nice, I guess, and enjoy. We also have a Slack community. Again, if you're not part of it, I really encourage you to join because we have, besides UX help channels, we also have a job channel where people post jobs and where people search for jobs, channels like portfolio reviews, and it's a great place to connect with fellow UX professionals. Well, and not only UX professionals. So yeah, we also we have a sponsor, which is UX Design Academy, and we offer a discount with discount code LUX. So the standard price is, as you can see, 2,250 euros, and the price for our members is 1,800. Quite a nice discount. Cool. And now to the topic of our event. And this is, I also have to mention that this event is part of a series of events for the World Usability Day. Basically, it's an annual sequence of events that happen in different cities of different countries, where people gather together and talk about how they can make technology more usable for humans. And every year it has a different topic. And topic of this year is human-centered artificial intelligence. And today, Nathalie will tell us about our role as humans in human-centered AI. And I'm passing my screen sharing to Nathalie now.
All right, let me quickly share my screen then. Okay. It's all visible for all of you? Okay, cool. All right, so our role as humans in human-centered artificial intelligence. Now, I want to start with a question. What if your future was affected by the outcome of an algorithm? And there's different ways in which you can interpret that question. Let's say you open Netflix and it recommends you to watch, like Notting Hill, and you end up watching it rather than working on your presentation, then sure, in some ways you can argue that your future is affected by what was recommended to you. And the same thing for buying something on Amazon or Bol.com. You can argue that your future is affected. Or let's say that you're writing an article in Google Docs, and you get a predicted suggestion of what you might want to type, and that might actually affect what you end up typing, like in this case. So your decisions already get affected by predictive algorithms all the time, and sometimes in very helpful ways, but not always. And so let me give you an example of that. Because of the pandemic earlier this year, I mean, the whole narrative in 2020 starts with because of the pandemic, but the final exams in the UK could not take place. And because of that, the examinations office there, called Ofqual, they created a grade standardization algorithm. And the main reason that they did that was to go against grade inflation. Because when you ask teachers to provide estimations about students' grades, they tend to be inflated. So they created an algorithm to moderate those predictions. And the problematic part starts by how they did that. So their algorithm was taking into account the previous results at the school. And what that means is that kids that were in high performing schools, historically speaking, like private schools with small classes, they were favored. At the same time, high achieving students in public schools, they saw their predicted grades being reduced and thereby actually losing university placements because they were measured against the school historic's performance rather than their own performance. Now, I love this quote because it really reflects what is unusual about this example. Because in this situation, many people, many kids across the UK were affected, including people who have a voice. And the thing is that decisions are increasingly powered by predictive algorithms. And a lot of times they're affecting people, marginalized groups very often, that don't always have the voice to speak up and also to be listened to. The good news in this case is that after all the criticism, Ofqual abandoned the algorithm, and they basically guaranteed that students could choose whatever was better, their teacher's prediction or the algorithm prediction of their final results. But the question that remains is really, what could they have done? Because to some degree, you can understand that they could not have really relied on the teacher's assessment fully because they tend to be inflated. But there's a huge space between putting this in the hands of humans, users, or completely automating it. Oh. And so rather than automating the decision, what if they would have chosen an approach that assisted the teacher? So augmenting the human capability instead, and accounting for all these different values that you see listed over here. And so as you may have guessed, that is a question that is really strongly linked to the field of human-centered artificial intelligence. Now, that's what I want to focus on in the next 25 minutes, to talk about our role as humans in defining and creating artificial intelligence in a human-centered way. So I personally work at a company and co-founded actually that company, Deus, where we focus on exactly that topic, human-centered artificial intelligence. My role is strategy, which basically means a whole lot of things, where I bridge whoever we're working with and our teams that we have internally. But in the next 25 minutes, let's focus on 3 topics. So first of all, let's start with, in a nutshell, what is artificial intelligence, just to get everyone on board. And as it's World Usability Day, like was just mentioned, and the theme of this year is human-centered AI, I'll go back in time a little bit to explore where this shift towards human-centered AI and the attention on this space is actually coming from. And then finally, together we'll explore the role of designers in human-centered AI through the lens of all the different themes in this domain. So to get started, what is artificial intelligence? Now, when I was studying artificial intelligence, which was about 8 years ago, it wasn't quite the hype that it is today. And I'm pretty sure that most people at that time really thought I was working on robots. In the end, you know, I was working on like classifying trees and such things. But now when you fast forward to 2020, most of us are aware that we're not talking about this. We are in some way, but the way that we use the term artificial intelligence reflects a lot more than robots, like in Ex Machina. But what are we talking about when we talk about AI? Now, to understand the field of AI, I think it really helps to look at the past to understand the present. So the field of AI was born in 1956 at a workshop in Dartmouth College. And at that time, a group of researchers, they basically proposed to conduct a study into what they at that time named artificial intelligence. And they basically formed that study on the premise that intelligence or learning should be able to be described in such a way that machines would be able to simulate it. And you can see that description over here in that corner. And the lovely John McCarthy, one of the founding fathers of AI, in the back. Now, right now, AI is described in many different ways, but I think a good and easy way to grasp your head around it is the field of study that aims to provide machines with the abilities to sense, learn, reason, and take action in ways that we would traditionally attribute to human intelligence. And at that time, or actually 10 years later, Nobel laureate Herbert Simon predicted that machines would be capable within 20 years of doing any work a man can do. Clearly, they cannot. And I mean, you know, as we're at a Ladies Like UX talk, he didn't even speculate on when they would become capable of doing the work a woman can do, which I'm pretty sure we're even further away from. But then the question is, how do you actually go about this? How do you try and make machines capable of sensing and reasoning and learning and taking action? They tried to do that in many different ways through expert systems in the 80s and some other methods. But then from the, let's say, early to mid 2000s onwards, what we consider to be our main technology in the field of AI is machine learning, which is about giving computers the ability to learn without being explicitly programmed. And the reason this has been taking off is largely to do with the rise of computer power and availability of data, cheap data storage. And when we talk about AI, oftentimes what we really talk about is machine learning. Now, I love this illustration to distinguish traditional programming from machine learning. So in traditional programming, you tell the computer what to do with very specific instructions. While in machine learning, you quite literally feed the computer data based on which it finds rules, patterns on its own to try and produce a certain output. Now, to look at a slightly more professional diagram of this, you can see it in this way. So you would have traditional programming where you have data and you specify a program, the instruction, computation happens, and you get to an output. With machine learning, or in specific supervised machine learning, you feed the computer data, examples, you specify a desired outcome. Based on that, you train a model, and then when new data is presented, that model is then able to predict the outcome. Now, this is supervised learning. You also have other types like unsupervised, semi-supervised, reinforcement, but I'll save those for another time. Now, I think a good way to think about this is by looking at another example. So this is an example of detecting cancerous cells on mammograms, which, if you think about it, how would you solve that with traditional programming? There's no set of rules that you could use in order to specify this. So this is a really typical case where you can apply machine learning, in specific computer vision, because it's simply not possible to describe those rules. But you can actually provide data, examples, and you have a desired outcome. So to bring it back to this model, and I think it really helps for you to, create a certain mental model of how these things work, is your data are the mammograms that are labeled with, is there cancer in this mammogram or not? That can be just the cancer status or fully annotated where it's actually marking the regions where there are cancerous cells. And then the desired output or your objective is to predict whether it's cancer or normal tissue. So you train a model based on that data until it reaches a defined level of success or accuracy that you set. And then when you introduce a new mammogram the model hasn't seen before, it's going to be able to classify based on the data it's been trained on whether it's cancer or normal tissue. Now, I want to encourage you to think about machine learning in that way, because if you have that mental model, it really helps you to make sense of, working on certain use cases or seeing these things if you're exposed to, and really moving beyond the definition of it's an AI system for marketing automation, but what is the AI part about it? So let's take Netflix and do a mental exercise of what data goes into making a recommendation, for example. Now, one other example to give is what happens in this case with Alexa. Let me just play this video and hope.
Play ticker ticker. Play ticker.
Bobby, can you talk to play wheels?
You want to hear a station for porn detected. Porno ringtone, hot chick, amateur girl, quality, sexy.
No.
Pussy, anal, dildo, ringtone.
Alexa, stop.
Yeah, so to bring back that mental model very quickly, you can imagine that, Alexa has been trained on speech, a lot of speech, to derive the words and intent, but it probably hasn't been trained on a lot of toddler speech. And it definitely wasn't trained on, recognizing that even a toddler was talking to it, because no adult in their right mind would respond the way that Alexa did here. And so it's very important to note that this entire process of machine learning is very human. It's in the hands of humans. Data is often about humans, by humans, from humans, or the world that they directly interact with. And the machine learning models, they're created by humans. Humans specify the desired output. And in turn, those outputs are then affecting humans. So I want you to think of that in terms of what power that brings into the hands of those who create machine learning models. And we'll get into that later. But even though this entire process is very human, the field of AI has actually largely focused on creating autonomous systems. And you could see that in the early examples. So Eliza on the left is actually one of the first chatbots that was created in the 60s, an autonomous chatbot. And you can also see that in the example of self-driving cars. But in the last few years, there have been quite some concerns around the notion of creating fully autonomous systems and whether that should really be the end goal. So if you're looking at self-driving cars, for example, in 2018, they recorded the first death of a pedestrian. Her name was Elaine Herzberg, due to a self-driving car. And you might argue a lot more pedestrians are killed on a daily basis because of cars that are driven by humans. But as long as self-driving cars still need human drivers behind the wheel, there will be confusion about who is accountable. Now, this is a research by Lex Fridman from MIT, where he's exploring what would then be the alternative to something autonomous like a self-driving vehicle. And in this case, he's looking at how you can create shared autonomy between humans and autonomous vehicles. And he raises the question in this paper that really is the question of automation versus augmentation. Is solving the driving task perfectly actually easier, or is it harder than perfectly managing the trust and the attention of a human being? And as you might have guessed it, this is an example of the type of questions that are raised within human-centered AI. And so it's about shifting the focus away from automation as the end goal towards augmentation. And rather than focusing only on algorithmic performance, so how accurate is your model, it's shifting the focus to human performance, which should sound, very familiar to you. It's about creating systems that are socially responsible, like fair, accountable, transparent, and also foster inclusivity. And they emphasize human needs, human control, and UX design. In the end, it should all be in the benefits of humans, and not certain humans only, all humans, and humanity, and enforce these fundamental rights around privacy and equality and democracy. Now, it's not a new observation that human-centered AI should be, the way to go. The fields of human-computer interaction and science and technology studies have been focusing on these topics for decades. But in the last couple of years, some institutes like this one, Stanford's University Institute for Human-Centered AI, were established really as a response to how AI is affecting people's lives. And also a bit in the light of the concerns around AI not benefiting people. Now, what is the role of designers in all of this? And I want to explore that question with you through the lens of these themes that are very strongly linked to what human-centered AI means in practice. So I'm not here to say this is your role as a designer, but I'm here to give you some questions and in some ways, design challenges that you can think about. What I want to ask you is to just think along with these themes, whether you work with AI or your work touches on certain applications or AI, or that's not the case. let's start with ethics. So ethics is one of the topics that's been getting a lot of attention over these last few years. And so many organizations are establishing ethical guidelines, also different independent institutes. But guidelines only have value when they're acted upon, obviously. But how can you determine what is a good outcome and for who that is a good outcome? Is it good for everyone? Is it only good for some people or not for others? And these are the types of questions that you typically want to be asking, but also really foster to include in the process of creating these technologies. Ethics is a massive field on its own, but let's take a look at one example that's commonly discussed, which are unintended consequences. So what you see here is TheirTube, a website created by Tomo Kihara, and it shows how different types of users get sucked into their own beliefs. Now, this should not be news for you because documentaries like The Social Dilemma and The Great Hack really have brought these types of issues to the mainstream. And especially when you're in tech, these are probably things you've heard of. But I found in the context of Donald Trump still not having conceded, I think it was worth it to bring it back a little bit. So in this case, it's an example of conservative content and what the YouTube page of a conservative person might look like. And as you can see here, this is far from over Rudy Giuliani. This is really reinforcing those beliefs. It's a very well-known example of unintended consequences. You've interacted with conservative content, you get shown more of that, because the model is optimizing for engagement. Now, we'll explore some other examples in the context of fairness later. The question is, how do you deal with things like this? And to put ethics in the context of AI, but also design, I think the work by Kenneth Valls is really interesting. So he wrote a book called Future Ethics, where he's really looking at how to combine the field of ethics with speculative design and future studies methods. So to translate ethical questions into practice. Now on the left, you see a speculative prototype of a charging station, and he calls these provocatypes. So this thing is not intended to enter the real world, it's there to provoke conversations. And the question here is, what if we would live in a world where energy is scarce? And what if an algorithm would decide who can charge their cars first? So should a doctor get priority over a convicted felon? Who should be prioritized? In the middle, you see these externalities prompts. And so externalities are people who are affected by your work that you might not have considered to be affected. And these also includes persona non gratas, so people you don't actually want to affect in the first place. Another example by the lovely Laura Summers are these ethical litmus tests. And she basically created all these prompts that are raising ethical questions. So you can include that to actually spark conversations and include in your process. So there are many different other tools that you can use, but in the end, ethics starts with the willingness and the commitment to even spend time on it and uncover the ethical implications in your work. And it often means that you actually need to slow down and take the time to have those conversations around ethics. It also raises a question about who should be involved in making these ethical assessments. If you have a very homogeneous group, people who are working on something, you might be more prone to overlook certain things when you have a more diverse group of people. Now, the field of ethics is strongly linked to fairness. So this is going to be the second theme of the human-centered AI themes to discuss. Fairness is interesting because there's no single global definition of fairness. It's always very contextual. And if you look at fairness in the context of algorithms, pretty much all definitions, they really focus on guaranteeing some sort of equality of a type of benefit across different people or groups. Now, when you're working with predictive algorithms, a really important outcome is to avoid creating or reinforcing biases that are leading to those unfair outcomes. So you need to be aware what types of biases might be aware in the data in order to be able to even start exploring how to correct for that. Let me give you a quick example. You might know this one. A couple of years ago, Amazon was exploring the use of an AI recruiting tool. And so they created this machine learning model that they based on the resumes that were submitted to them over 10 years. And then, they looked at who went on to get hired and who went on to succeed within the organization. And what happened was that it ended, teaching itself that men were preferable. And that's not really a surprise if you look at the data, because, most resumes came from men, and that only reflects the type of male dominance that simply exists in the tech industry. And as a result of that, it ended up penalizing resumes that included words like women's and things like women's chess club captain or women's rowing club captain whatsoever. So to debunk that a bit and going back to this diagram, fairness, whether with intention or not, is decided by humans. It is not decided by algorithms. It is decided by the humans who make these algorithms and the organizations who put it out to the world. And the algorithms, they're only learning what is present in the data, which is chosen by humans. And that can reflect historical injustices or, like in this case, gender bias. So if you know that your history wasn't perfect, which, let's be fair, it rarely is, you know that you're gonna have to correct for those imperfections one way or another. The good news is that the machine learning community is actually aware of these challenges, and algorithmic fairness is quite a growing discipline right now in machine learning. And to give you a very local Ladies at UX Amsterdam example of that, here in Amsterdam, recently the Civic AI Lab was started to research some of these areas and also to explore the fair use of artificial intelligence. And so they're focusing on topics like how to maximize fair resource distribution in education and equalizing access and treatment in healthcare. Definitely a recommendation to follow their work or get involved. But for now, let's move on to accountability. So starting here, I recently interviewed a professor who focuses on bias, and his name is Ricardo Baeza-Yates. And one of the things he mentioned that really stuck with me is that in many languages, there's not a word for accountability. I was thinking about it in Dutch for a very long time, and I was like, oh, responsibility in Dutch is very obvious, but not actually the word accountability. We rarely use it in Dutch. So as we're with quite an international group, I just want you to think of whether the word accountability actually exists in the languages that you speak. And if not, I'd love to hear about that later. But the question with AI systems is often, who is accountable for what happens with it? Is it the organization, the teams that are working on these things, the end users? Is there a point where your responsibility as makers ends and the responsibility of the user begins? Now, to just bring it back to Europe and GDPR, GDPR basically states that businesses are accountable for handling people's personal information. So they need to be able to demonstrate and often document how they're complying with data protection law. But this really concerns personal data. What about accountability, let's say in the autonomous vehicle example, or even when your technology platforms like YouTube or Facebook are used to influence elections? Who is accountable? This study by Stack Overflow is quite interesting. So in 2018, they basically conducted this development survey, and they focused on AI in particular. And they asked developers who is primarily responsible for considering the ramifications of AI. And so as you can see on the right, actually almost half the developers of these 60 or so thousand, they think that they carry this responsibility. Now, at the same time, they indicated that developers are not sure how they would actually report ethical problems, and that they have quite differing ideas about who is ultimately responsible for unethical code. But how can and how should we go about making and using AI systems while also holding them accountable? And accountability, that is very strongly linked to transparency and explainability. So models which are able to explain in human language how a decision has been made. Now that's the next topic here. So transparency is important for many reasons. One of them I just mentioned, accountability, complying to regulations, but also for gaining the trust of the humans, the users who are going to use the system. And also even to verify whether your machine learning model is working or not. To understand this a bit better, let me give you one of my favorite examples. I love this one. So in a study, researchers wanted to create a machine learning model that could distinguish wolves from huskies because they're actually very similar, you know, so it might be quite a challenge, they thought. And they actually managed to get to an accuracy of about 90%. But what turned out was that the model was actually basing all its decisions on the background, because wolves are often photographed with snow in the background, where huskies are often actually not photographed with snow in the background. So what they built was a snow detector. Now, by only looking at the accuracy, you wouldn't really have been able to spot that. But imagine this was your mortgage application. And this is something the financial industry is dealing with when they want to apply machine learning to, let's say, evaluate whether someone is suitable to apply for a mortgage. A person cannot simply be denied of a mortgage without any explanation. So the question that needs to be answered is, how can we explain based on, let's say, what variables this output was generated? So this is where the field of explainable AI comes in, and also the trade-off that you make between accuracy and explainability. Now, you have different types of machine learning techniques. Some of them are simply more inherently explainable than others. So linear regression, for example, is very easy to explain, whereas neural networks, they take into account sometimes millions of variables and are thereby harder to explain. Now, you can look at the explainability in different ways. More and more developments are taking place to also increase explainability in the more complicated models. But you can also look at explainability before you even start building something, rather than looking at after the fact. Now, one of our master thesis students, now colleague, Willem Friese, he conducted research on this topic earlier this year. And he basically looked at what are the pre-modeling considerations in terms of explainability. And so by determining, the needs of the different stakeholders, what factors can you actually, use to take into account to help you inform what type of model you might want to be choosing for a certain application. Time to move on to another topic, which is human agency. Now, human agency is the capacity for humans to make choices and also impose those on the world. So when you think about human agency, it's about questions like how can we augment human capabilities and also allow humans to simply make choices? And what level of autonomy is even desirable, like in that autonomous vehicle example? Now, for many current AI systems, like recommender systems, they're trying to kind of replace our decision-making process to a certain degree with predictions of content, which we like, what we would like, most. What type of content would we want to engage with so we can stay on the side and keep using that service? So like in this example, something we always interact with, and this is why my Medium page is filled with topics about AI, probably yours maybe not, but you get sucked into this bubble, you're promoted the type of content that you've interacted with and are likely to interact with again. But how can we think of this in a way that actually promotes human agency? So where systems would support our decision-making rather than replacing them. Now, this is an example by Caroline Sinders, and she's a machine learning design researcher and artist. She's very amazing. You definitely need to check her out. And in a talk, she explained basically how she ruined her Spotify weekly algorithm because she broke up with a boy and she kept listening to Mumford & Sons. So what she did was she came up with this concept, which is a really nice way of thinking about how we can actually give agency and control to humans when using these self-learning predictive services. And in this case, it basically allows you to edit your data, so you can say, hey, I do not like Mumford & Sons anymore. Found a new boy. So it's a good example of applying a predictive model while allowing humans to make choices and impose those choices. This topic should ring a lot of familiar bells at the Ladies That UX meetup. And I'm pretty sure we're familiar with topics like human needs, the desirability lens, etc. But to put it in the context of AI, I think there are some interesting challenges in terms of human AI interaction. So let's explore a couple of examples. Now, this is an example from the Google team, where they basically created a feature to help users decide whether it's the right time for them to buy plane tickets. Now, clearly, this is not a feature we would build in 2020. And I definitely miss those days when, booking a ticket to Japan was on my list. Anyhow, this is an example that quite nicely is linked to the topic of providing that transparency and explainability to encourage trust in users. So they wanted them to be able to make confident decisions. And they do that in two different ways. So in the user interface, which you can see over here, they indicate whether the price is low, typical, or high compared to the same dates in previous years. But they also explain how confident they are whether prices might change or not. And so rather than saying we're 90% confident that prices will not change, they're saying that in very human words, prices will generally go up. Now that Google Flights example is a very narrow application of AI. It only needs to predict one thing, flight prices, and do that well. Another interesting example of human AI interaction with a human fallback option was Facebook's M. And they started Facebook M, this chatbot, in 2015 with the end goal of creating a chatbot that would be this super assistant and could do like anything its users desired. And so when a user makes a request for M, it basically determined what a user wants. And if M doesn't understand, it would hand over the task to a human. And so in this case, our Matthew over here, he wanted to order some parrots to bring to Kevin's office. Now, as it turns out, that is not a thing that M could do. So a human stepped in and took over. But creating something that is as broad as what M aspired to do is really hard. And the technology is simply not there yet. And so M was discontinued, but I think it is quite an interesting example of looking how you can foster human AI collaboration. And you see some examples of this in customer service, where you have a service agent that gets prompts, suggestions that were predicted as the next answer, and then the customer service agent then goes and decides what prompts to give. So it's human AI collaboration rather than automation. It's really nice that many organizations are actually seeing the needs for more defined guidelines for human AI interaction. So this is, for example, one by Microsoft, which really focuses on providing people designers, making these systems with considerations to take into account. And then finally, for our last topic, tested. Now, this is not necessarily a theme that is specific to human-centered AI, but I thought it was quite important to include it. Because like I mentioned before, human-centered AI, you want to focus on testing beyond algorithmic performance, testing human performance and human definitions of success. But also because machine learning is quite different from traditional software testing. Your inputs can vary a lot more widely, and it's safe to say it will fail. At least sometimes. So how do you make sure that it feels the right way? Now, this is a very harmless example of voice assistant fails. By the way, this is not my screenshot nor my boyfriend's, but anyone who has interacted with a voice assistant before, they know that these things happen, and sometimes they can be quite hilarious. Other times they might not be so hilarious, like in this chatbot case, for example, pretty painful. But in some cases, the cost of an error is really, really high. And if we think back to the mammogram example from before, what is the cost of a wrong prediction? And a very basic way to explore that is by looking at the consequences in all the possible scenarios. So this is a confusion matrix, which is helpful to evaluate the cost of an error. So true positive means you made a correct prediction. The patient has cancer, and that is predicted that way, so the patient can get treatment. Now, a true negative is also okay because it's a healthy patient. The patient hears that he's healthy and he leaves, all good. Now, a false positive means that a patient is predicted to have cancer, but actually does not have cancer, so may get scared, might be admitted for a trial, but is actually healthy. And then a false negative is the extremely costly one. So the patient would go home feeling relieved that he's not sick or she's not sick, but is actually sick and doesn't receive treatment. Now, these types of matrices, they can really help you to inform whether you want to optimize for a couple of false positives in order to reduce false negatives, which are extremely costly. So we've briefly touched on the most important themes of human-centered AI, even though it's by no means possible to spend enough time on each of these themes in half an hour. I even think I went already quite a bit over that half an hour. But as you could hopefully see emerge from those themes that we discussed, is that all these topics are very interdisciplinary. It's not just about computer science or data science. We need to collaborate across fields like ethics, social sciences, human-computer interaction, and design. And we also need to foster inclusivity and make sure that we involve diverse perspectives, minimize blind spots through that. And then finally, I really think that it starts with awareness, and we can really not expect to be an expert, that everyone is an expert in data science and design and everything else that needs to be done to actually get to where we want to be going. Each of those things is a whole discipline on its own, and it takes years to master one of those. But I think that being aware of some of those challenges that we face in the field and acknowledging that when we make those systems, we have the power to influence people's lives for the better or for the worst. And so through this talk, I hope that I at least have contributed a tiny little bit to your awareness and encourage you to explore some of these topics further on your own and what your role as a designer could be. So I think I've talked more than enough. So I'm very curious to hear about you.